Welcome back. Today we'll be looking at how to build up rate for electrical works, part 2. From our part 1, I laid the foundation. Today I'll be continuing from where we stopped. Today I'll be walking us through the journey of power production from the generation plant down to our build. I'll be running us through that process quickly. Okay. We have different people watching all over the world. So I'll be using Nigeria as a case study. So, we'll be able to learn and then apply it to our various countries. Okay, so please pay good attention as I run us through the process. So in Nigeria, our generation plant is called GenCos, right? Generally, they produce 11 to 25 kilovolts of energy. It's been stepped up to 132 kilovolts for transmission. The reason why it's been stepped up is because when power travels, you will lose some of the energy. So that's why we have to step them up. Then it's been reduced at our substations to 3 to 33 kilovolts. The reason why we are stepping it down is for us to be able to distribute them. Okay, so it's called discos. So we'll step it down and then distribute it to the distribution companies. It's called discos, so that the distribution companies can distribute this energy. So it's being stepped down to 33 kilovolts. The discos further reduce this voltage to 11 kilovolts at the primary distribution substations. Okay, then finally we have our local distribution, which is our transformers and all. Then our transformers step further step it down to 11 kilovolts, which so you now step it down from 11 kilovolts to 415 to 240 voltage, which is now supplied to our houses and our offices. Okay, so this is the journey of how power is being generated, how it's being transmitted, and then how it's being distributed. So we'll be looking at some things that I'll be explaining here. I'll be sharing my screen now. Okay, so before I share my screen, I'll be looking at I'm sharing my screen now so that we could further look at the things that I'm trying to further explain. Okay. So here I stop at the power from a transformer. We'll be bringing the light here. So we have two sources of power, our PSCN, and then we have our generator. So here we are using a 50 kVA soundproof generator. So this is a schematic drawing. I'm trying to explain some things here. So we're using two cables here, 4 core by 35 mm PVC copper cable. The second one is 1 core by 10 mm PVC earth copper cable. Okay, that's what will be you connect the generator and then the power, from our PSCN. So we'll be connecting them to our ATS, which is called automatic transfer switch. This switch here helps us to be able to regulate our PSCN and our generator. The moment the light goes off, automatically connects the generator, which it picks automatically. So this switch does that magic. Okay. From here, we also have the same cable that run through our main panel. It's still the same cable, 4 core by 35 mm PVC copper cable, 1 core by 10 mm PVC earth copper cable. It's been connected to our main panel, and our main panel is where our distribution board is being connected. Okay, and then we also have 3 extra spaces. I've explained what a distribution board is earlier, and then I also gave a breakdown of the things that is needed in a distribution board. So please, this will be the end of part 2. Follow us, like, share, comment from the description page. You get all the templates, and then you get the PDF of this class. We move to the next one. Thanks for watching.